ACE Podcast.
Hello, and welcome to another episode from Series 1 of Vaguely Accurate, the science show where we speak to the next generation of scientists. I'm your host, DK, and today with us we have Tom. He is a sleep scientist from here in Australia, and I suppose, Tom, would you like to introduce yourself?
Yeah, sure. My name's Tom. I yesterday submitted my honours thesis on sleep architecture.
Congratulations.
Thank you very much. So sleep science really kind of began in the 1930s when they started using, or when they invented electroencephalography. So when they were able to measure brain waves of people. Because before then, really the only way of measuring sleep was behaviourally. So sleep science really began as a kind of a niche field in psychiatry in the 1930s.
And I suppose, what is the benefit, or what is the point in having a sleep science?
It's a good point because it's really interesting. That's what I would probably say first. Because sleep is one of the greatest mysteries that we currently have about life and biology in general. I think that and why we die. Sleep has got to be one of the biggest enigmas. But there's tremendous practical value as well because of sleep disorders, particularly obstructive sleep apnea. I mean, that's just so prevalent, especially in modern society, Western cultures. It's characterized by kind of intermittent periods of respiratory obstruction during sleep. So what's happening is that as the muscles in your airways and your upper airways kind of relax, when you sleep, they collapse, and then you asphyxiate partially, and then wake up. Not really wake up partially, and then you start breathing again, and this kind of happens in cycles throughout the night.
Do they know why that happens yet?
Yeah. There's a lot of factors involved, like the shape of your face, like the craniofacial, I think that's what they call it, craniofacial abnormalities will contribute.
Okay. Being
quite obese, having a lot of weight around the neck.
Yep.
Of course, because when you're lying down, the gravity will affect you.
So they all sound rather physical as symptoms.
Yeah.
How would studying the aspect of sleep
Well, with sleep apnea, you need to be able to diagnose it. And so we wouldn't really be able to diagnose it without sleep science. So how obstructive sleep apnea is diagnosed is it's diagnosed in a lab. Someone will come in and then they'll get into bed and they'll get wired up with a whole bunch of electrodes, including the EEG I was talking about, and some other measurements which measure muscle activity, like on the legs or on the chin, and then there'll be some measurements of respiratory measurements, so like a nasal cannula connected to a pressure transducer.
So would that, instead of being equipped up with all those instruments, as a patient, you're trying to measure, I suppose, their natural sleeping state, would that not impact their ability to sleep?
Yeah, it does. It definitely changes. Being in a lab environment changes sleep, and that's pretty well reported. But if for the purpose of diagnosing sleep apnea, it's not too important because sleep apnea it'll kind of manifest itself if you're asleep. If you're asleep, it's going to happen. If it does happen when you're asleep. If that makes sense.
So it's developed from psychiatry initially, as you said, historically.
Yeah, the first people to study sleep science were psychiatrists. So you kind of have to think it wasn't really much of a science before EEG because there was no real way of measuring sleep. They kind of did experiments on animals, like
observational.
Yeah, observational stuff. I read a couple of papers. During the 1940s, I think the title was Some Experiments on Puppies. It was not pleasant reading. They just subjected the puppies to sleep deprivation and then cut them up afterwards. And that's what sleep science was.
1940s,
in circa 1932.
1940s were great for ethics of science, weren't they? Can you tell us a bit more about your research? So you've just finished your honours, correct?
Yeah. So it wasn't really my research because I was using archival data.
Okay.
The West Australian pregnancy cohort otherwise known as the RAIN study, was a study started about 25 years ago on pregnant mothers, investigating ultrasound, I think it was. And from then on, they just kept following the children from those mothers at regular periods of their life. So that there's been follow-ups after the first year, the second year, the third year, and kind of a new kind of focus for testing happens on each follow-up. The 20-year follow-up, the focus was on sleep. So all the participants, 950 in total, came in for sleep studies, polysomnography, what I was describing earlier. That's where my data was.
So from all these children / adults now.
Kids, well, they're actually our age. They're pretty much now. Exactly our age. And they're all born in 1990, 91, 92, 89, yeah.
Kind of feel like you've been sold off a little bit when you wake up, when you're born and then you find out you've got to do a scientific experiment for the rest of your life. Like, it's a bit rough.
I think they're good sports actually for the most part.
Well, what were they researching if they did sleep?
Yeah, so the real main focus in sleep right now is incidence of respiratory disorders during sleep, like obstructive sleep apnea. That's a big focus, just because it's got the biggest health consequences generally. So the data was collected with the purpose of assessing the sleep disorders in young adults.
Yeah.
There's been really, really little investigated in young adults for respiratory disorders during sleep. So that was the purpose of the research. So I was just kind of jumping on and using their data, which is very nice.
And with your research particularly, you were using this data.
Yeah, I was using the sleep study data.
Yeah,
the polysomnography data.
And I suppose, what were you doing with it?
All I was looking at was sleep architecture. So sleep architecture is what we call the structural organization of sleep stages within a single sleep period.
Could you give us a rundown of what the stereotypical structure is?
Yeah, so I mean, it looks, to the exterior observer, sleep seems kind of simple. You're unconscious, you fall asleep, you turn around a few times, and then you wake up in the morning. But actually, there's a really complex and interesting thing that's happening biologically. So by measuring the brainwaves, we see a general kind of evolution of kind of the pattern of brainwaves throughout sleep. So first, people move into stage 1. And that's kind of the lightest stage of sleep. That only lasts for maybe a minute, maybe even just 30 seconds, until you move into stage 2. And stage 2 it's kind of, medium sleep, you could say. From then on, maybe after about 20 minutes, to move into stage 3. You could probably call it the deepest stage of sleep. It's very hard to wake someone up in stage 3 sleep. And during this stage, your brainwaves are huge amplitudes, really slow undulating waveforms, really quite dramatic to look at. And next comes rapid eye movement sleep, which I think a lot of people know about. That's when the crazy dreams start to occur. And your brain activity, or the activity of the cortex during REM sleep, it's more active than some periods of wakefulness.
And REM sleep stands for rapid eye movement.
Yeah, REM, rapid eye movement. After that progression, 1, 2, 3 REM.
Yep.
We go back. We'll start again. 1, 2, 3 REM.
Do they know why there's this cyclic kind of pattern going on? No, they don't.
No.
Okay.
No one's got any idea why that happens. No one knows what REM sleep is for. No one really knows what the other sleep's for either.
What the first stage?
Yeah. So stage 1, 2, 3 is non-rapid eye movement sleep.
Yep.
And REM, is rapid eye movement sleep. So the first 3 sleep stages are non-rapid eye movement sleep. They didn't notice REM sleep for about the first 20 years of EEG-related sleep research.
Oh wow, okay.
So they didn't think of measuring any electrical activity near the eyes. So they only figured it out 20 years later, which kind of pissed them off a little bit, because they'd be coming up with some really great theories relating to how the progression of non-rapid eye movement states go.
Yeah.
And finding rapid eye movement sleep it kind of threw a spanner in the works. They didn't really know what to make of it. And quite interestingly enough, we still don't know what to make of it.
I suppose a question a lot of people might be curious about is, at which stage would you dream? What are dreams? Can you answer that?
There are dreams in... I think there are dreams in every stage of sleep, but the dreams become much more frequent and more vivid during rapid eye movement sleep.
Okay.
Yeah.
And they don't know, again, I suppose, why that is?
I should say I don't.
Yeah.
Probably. I think the answer to a lot of questions relating to sleep is I don't know. in general. It's we still don't really know.
Before moving on, do you happen to know what lucid dreaming is? And if does that actually occur? Is that a myth?
Oh, no, what lucid dreaming can't be a myth because people do it and they tell you how they do it. Yeah, I don't know.
But I find like listening to someone telling you how they do it and how to do it, if you can't physically measure it, then how do you take what they say to be true?
Okay, well, you might want to define what you mean exactly by lucid dreaming first. Having some degree of control in your own dreams. What you think it might just be a kind of an illusion to people that they're having some control? It's an interesting idea. I've always just taken people at their word and...
Yeah, like I've never seen any kind of measurement of it or any kind of... I mean, can you stick a polygraph on someone during a state of lucid? I'm sure there have been studies for that.
I heard about some research. A previous honours student, I think it was last year or the year before, was talking to me about something he was doing with lucid dreaming. He was trying to elicit lucid dreaming using some kind of exterior electrical stimulus. But I haven't read anything about it. I'm not too sure about the lucid dreaming. I did when I was younger. I did look up a few techniques to try and do it, but it all seemed to be a lot of hard work. I think there are probably easier ways to obtain altered states of consciousness. Okay, yeah. Well, I was talking about sleep architecture, wasn't I?
Yeah.
All right. So the sleep architecture is the structural organizations of sleep stages within a night. So those sleep stages are stage 1, light sleep; stage 2, kind of medium sleep; stage 3, deep sleep or slow wave sleep, whatever you want to call it; and then rapid eye movement sleep.
Yep.
And this alternates 1, 2, 3 REM, 1, 2, 3 REM. These happen in cycles about 3 to 7 times in a night, which is different for every person. Some people might have 3, 4. Some people might have 7.
Yeah. So
the frequency of this cycling is different for every person. So this is sleep architecture. What my research was just looking at sleep architecture in these young adults that came into the lab and just obtaining some normative data on them. Because it's a really large sample size, especially for sleep-related research. Having 950 participants is a really big deal.
Yeah.
So I think the idea was just to get some normative data from them and present it. Yeah, that was the primary aim.
What did you find out?
Well, we found out a couple of interesting things. So there is well-reported age-related decline in some polysomnographic features. So some of the features of sleep that we look at in sleep science. So as we get older, we tend to sleep less, and that's more to do with wakefulness, intervening wakefulness during our sleep period. So we're awake more when in bed. We're awake more the older we get. Also, so sleep efficiency, which is how we would say how much sleep you have in your sleep period. So you turn the lights off.
Yep. Sleep period's defined just as when you get in bed and your intention is to sleep. Yeah,
when your intention is to sleep and then you get up afterwards. That's the sleep period. And so your sleep efficiency would be your total sleep time divided by that sleep period.
Okay.
So it's kind of a percentage.
Yep.
And that tends to decline as we get older.
Yep.
It seems to, and most changes tend to happen in males more than females. So the stage 3 sleep that I was talking about, the deepest stage of non-rapid eye movement sleep, declines profoundly in males, quite a bit.
At what age? Like, we talking mid-20s?
So that's a good question, because that's what's related to my research. It was the most profound change happens from about 30 to 40, and then 20 to 30. I think there's quite a bit of decline as well. So what we found was that there were differences in the amount of slow wave sleep, small differences, but they were still there. There were differences between the males and females in that sample, which means that whatever age-related decline in sleep with men is actually happening pretty much from maturity onwards. So It's interesting because no one really knows why that's happening.
To summarise, I suppose what you found from your research is you were looking at sleep occultation. You found that males decrease in sleep efficiency as they get older much faster than females.
Well, I didn't find that in my research.
Okay.
So this is something that's been pretty evident in the research up until now. But what wasn't really known was when those changes start to occur.
Okay.
And the reason we found it in this sample is because it was just such a large sample size. We had a bit more statistical power.
Yeah.
And we're able to actually detect.
With this decline in age, would shift work for an individual be more optimized by a younger individual or an older individual? Because I assume shift work, I've heard that shift work really screws with your sleeping pattern and everything.
I've heard that also.
So if your sleep efficiency is declining as you get older, does that mean your shift work, you may not be able to recover from your shift work as quickly?
Getting older is going to impede your recovery in terms of shift work, definitely.
Okay.
Yeah, older people struggle more with shift work than younger people.
Yeah.
Yeah. There's been that is backed up by research quite a bit.
Is there any kind of, I suppose, mental or physical connotations to struggling with shift work? Do you happen to know?
I think it depends. There are people have different what we would call chronotypes.
Yeah.
So a chronotype is if you're a morning person or like a night person, basically a lark or an owl. There's many ways to say it. So I think the owls, the late chronotypes, would probably deal with shift work more easily.
Cool. So I suppose what's next for you now? Like you finished your honours.
Yeah.
Is there a lot of work in sleep science? I imagine it is, like we were just discussing, quite shift work related.
Yeah, it is. If you don't like shift work, then perhaps working in a sleep lab's not a good idea. Sleep medicine is a pretty rapidly expanding field, so it'd be a pretty good area to look into for getting a job for anyone who's wanting to do something biological science related or in the health sciences, something like that, and they're interested in it. Yeah.
What kind of work is there? I mean, I suppose is it all kind of tech lab based?
Yeah. Well, apart from being a sleep physician, there's roles for technologists and technicians. So people are needed to wire the participants up, or the patients up with all the diagnostic equipment, and we need people to monitor them overnight, and there needs to be people to analyze the data as well. So there's a lot of roles there.
And you use the term sleep physician. Is that a medical doctor who specializes?
Yeah, a medical doctor that specializes in. Most of them will be respiratory sleep physicians because most of the major disorders that happen during sleep are related to respiration.
A fun question: can you sneeze in your sleep?
I had to look that up when you asked me before. I googled it. Apparently you can't.
You can't.
Yeah.
I imagine you can. People cough in their sleep, but sneezing is quite, I suppose, a vigorous activity for your body to exert. I suppose that amount of force. And I imagine
I think
it would be hard to wake up.
I think from a common sense perspective, you'd probably wake up to sneeze if you really needed to sneeze so badly.
Yeah.
Yeah. I think that's related to the other one though, is that no one really knows why we yawn.
Do they not?
No.
I always, I mean, maybe it's a wives' tale, wasn't it? Just like to increase the oxygen saturation levels.
Yeah. So that's I think apparently that's an urban myth.
Oh, really?
No, it's not true. Yeah. Apparently, it doesn't really do anything to your oxygen, which does make sense because when you think about it, if you want more oxygen, you just breathe deeper, don't you?
No, that's true. And I suppose if your oxygen's depleted that quickly, then it's probably a worrying thing.
Yeah, I looked this up a while ago, but there's some theories. Some people think it might be a brain cooling mechanism.
Okay.
Yeah.
So when you've been working too hard, your brain's overheating almost.
I think most of these theories are related to it's kind of maybe an evolutionarily throwback. So it doesn't really have much of a purpose in humans at the moment, but it may have had a purpose in whoever we're descended from.
It's a primal mating call.
Yeah, maybe. Well, that's the thing. Is
my yawn.
Yawns are contagious.
That's true.
So there's a behavioural thing involved.
I'm almost
in there
tempted
as well.
now as we're talking.
Yeah, and now we're talking about yawning. I feel that I should do it.
Have you got a take-home message for anyone that's listening? Maybe something that's commonly misunderstood, or anything relating to your field that you feel like you're passionate about?
Commonly misunderstood. There's probably heaps of those things. Maybe the myth of people don't think that it's that necessary. I'm not actually sure if there's anybody that still... Do people think that?
That sleep isn't necessary?
No, it's really important. If there's a take-home message, that sleep's really, really important. We don't know why.
8 hours?
That's the recommendation, is 8 hours. But I know that I don't feel 100% after 8 hours sleep. I'm more of a 9.5 kind of person.
So maybe it's an individual thing similar as to their stages of sleep.
The frequency of your cycling relates to how much sleep you need. Now that's a real good question.
Higher frequency, less sleep, you'd hope. So if you went through your stages quicker, then...
In the data that I was looking at, the subjects that slept that had really very short sleep cycles, so they progressed 1, 2, 3 REM, 1, 2, 3 REM more quickly, they tended to sleep longer.
Oh, really? So
yeah.
Wow.
Well, no one really knows much about the frequency of sleep cycles and why that occurs. But it could be related to depression somehow. I think there's been some research looking at a shortening of the sleep cycle in depression. So it could be that those and in depression people tend to sleep longer as well. Yeah. So there could be something there. I'm not sure. The real mystery is why we do it to begin with. A single theory of sleep really it doesn't exist at the moment, and we can point to things that happen during sleep and say
a great field if anyone really wants to get the name out there, and they want to be the Einstein of sleep, or
maybe it's a great field to be involved in if you want to be frustrated with how little we know, or excited. I don't know. Well, I think the main reason that we still don't know too much about it is it's just a really, really complex phenomenon, and it's going to need a lot of research to actually pick apart what's going on.
So for you personally, are you going to continue with research, or are you going to...
I have no idea.
You have no idea?
I have no idea.
Lastly, if there was what would you say is the most likely apocalyptic scenario that would derive from your field of science, I suppose?
So if there's something that I could find that might cause the end of the world, is that what you mean? I'm not sure about that. I'm not sure that I would be able to be responsible for an apocalyptic scenario. Or just sleep-related, perhaps?
Yeah, anything sleep-related in that kind of field. Was there, sleep-deprived zombies? Is there something...
There is this really...
It doesn't have to be realistic, sci-fi kind of...
Well, there's this rare disorder, I can't remember what it's called. But it's very rare, but it pretty much means that you're completely unable to sleep. People, they just go mad and then die.
That's not good for you.
No, not at all. In a matter of about 2 to 3 weeks, I think. Oh yeah, maybe look it up. I can't remember what it's called.
Fatal Familial Insomnia.
Yes, Fatal Familial Insomnia. Yeah, that's what it's called.
It's an extremely rare autosomal dominant inherit prion disease of the brain. That's
what? It's a prion disease, really?
Yeah, whatever that means. Can you tell?
Okay, yeah, so there's 3 major infectious agents: parasites, bacteria, and viruses.
Yep.
And there's also another one, is a prion. A prion is a misfolded protein that has the ability to misfold other proteins.
So it's like a contagious mutated protein.
It's not mutated. The protein's not mutated. The protein, when proteins are constructed by the cells, they need to be folded, and the folding, I think, gives it the protein its final form or final shape, and for whatever purpose it needs to serve. And so sometimes misfolding can occur, and the prion is a misfolded protein that has the ability to misfold other proteins. So mad cow disease is a prion.
So what we have here is fatal familial insomnia has no known cure and involves progressively worsening insomnia, which leads to hallucinations, delirium, and confusional states like that of dementia. The average lifespan of a patient's diagnosis
3 weeks
FFI after the onset of symptoms is 18 months. 18 months.
Hell, 18 months.
Sleep. That would cause, if everyone simultaneously caught that, I would agree with you.
That's my apocalyptic scenario. Everyone suddenly contracts fatal familial insomnia. Well, that's interesting. It's a prion disease because that means that it's possible that someone could catch it. Maybe it could be induced in someone.
The mutated protein has been found in just 40 families worldwide, affecting 100 people. If only one parent has the gene, the offspring has a 50% chance of inheriting it and developing the disease. Ouch.
Yeah, so if anyone looks like they're really crazy and hasn't slept in a really long time, don't have babies with them. That's a
take-home message.
That's a take-home message. Don't have your kids have fatal familial insomnia. Well, that's interesting. I think because Creutzfeldt-Jakob disease is a prion disease, and that has similar or related diseases that are transmissible.
Okay.
Yeah.
So what is that disease? What does that cause?
It's a neurodegenerative disease.
Yeah.
Yeah, and the transmissible is Kuru, which is a disease endemic to, I think, certain regions of Papua New Guinea. No, what they worked out, because why this was happening in these Papua New Guinean villages, it was only certain family members that would get this particular disease. So these Papua New Guinean tribes were cannibals.
Yep.
And as part of the mourning process, different members of the family got different parts of the body.
Okay.
So maybe figure out what part of the body causes the disease.
I want to see the ethics argument for that proposal. That'd be incredible. Trying to...
I can't remember what family member gets the brains, but I think they're fairly low down.
Yeah.
I think the brothers or the fathers, or the brothers or the sons or something get to eat maybe the buttocks or the prime cuts.
The cuts.
Yeah, the good bits, but I think some of the distant family members who were female got the short end of the stick and got the brains, and then contracted a spongiform encephalopathy. Yeah.
Well, I suppose we'll call it there, if that's right. Cool. Unless you have anything else to share?
No, I've already wandered pretty far off topic. I'm not sure.
I love wandering off topic, so you get some interesting stuff. I suppose that's it all for the show today. Cheers, Tom. I hope you've learned a lot. I know I certainly did. Before we go, I have a few announcements. Firstly, if you enjoyed the show, like always, follow us on Instagram, Facebook and Twitter. Share us with your friends and family. And if you yourself or you know anyone that may be interested to feature on the show, or you just want to throw us some feedback, please contact us. You can get in touch with us by our email of vaguecomments@gmail.com, or you can check out our website, which you can find on our Facebook page. Also, if you want to read a little bit more science, we are now going to be releasing regular articles on our website. And lastly, most excitedly, we have a big announcement that we've just joined a new podcast network. It's a community-based podcast network called Ace Podcasts. That is, I suppose, is a friendly advice podcast where we're sharing cohorts of listeners. And if you're interested in any other shows, check out the website, acepodcastnetwork.com. They've got a Facebook page as well. Be sure to check on that and like it. Yeah, and if you're interested in being part of the network also, get in touch with them. They're great, friendly guys, and it's a good community to be involved in. But I think that's all. It's quite a mouthful there. So thank you very much, guys, and look forward to hearing from you soon. Bye.
No puppies were harmed in my experiments.